Welcome to The Explainer. Today we're breaking down two powerhouse techniques that you absolutely need to know for any coding interview: memoization and tabulation.
So here's our game plan for this showdown. First, we're going to look at the problem that even calls for these techniques. Then, we'll meet our two contenders. We'll watch them go head-to-head in a couple of classic challenges, check the judge's scorecard, and then most importantly, figure out which strategy you should choose.
So, first things first, let's set the stage. Why do we even need something called dynamic programming? Imagine your code is just stuck. It's in a loop, doing the same exact work over and over and over again. This is a massive waste of resources, the absolute enemy of efficiency, and it's precisely the problem we're here to solve.
And the solution, which we have thanks to the mathematician Richard Bellman back in the 1950s, is actually kind of brilliant in its simplicity. The big idea is solve each small problem just once, and then remember the answer. That's it. This simple concept can take an algorithm from being painfully slow to lightning fast.
Now, dynamic programming, or DP, gives us two main ways to do this. And this, right here, is where our big rivalry begins.
All right, let's meet our contenders. In one corner, we've got Memoization. Think of it as the clever, top-down planner. And in the other corner, we have Tabulation, the methodical, bottom-up builder. Two very different styles, but they're both aiming for the same goal.
So here's the key thing to get about memoization. It is demand-driven. It starts with the big, final problem and uses recursion to work its way down, asking at every single step, hey, have I solved this little piece before? If the answer is yes, it just grabs the solution from its cache. If not, it solves it and then stores the answer for next time.
Tabulation, though, it's a totally different approach. It is systematic. It doesn't wait to be asked. Nope. It starts at the very beginning with the simplest possible cases and uses loops to build its way up, filling out a table of answers until it gets to the one you actually want.
All right, round one. Ding ding. Let's see how our contenders handle a classic coding warm-up, calculating Fibonacci numbers.
Now, the rule here is super simple, right? Each number is just the sum of the two before it. But if you try to solve this with just a simple, naive recursion, oh boy, it gets slow, fast. You end up recalculating the same values constantly. But our two contenders, they're way smarter than that.
So, memoization attacks is from the top. You ask it for, say, Fibonacci of 10. It immediately tries to calculate 9 and 8, and so on all the way down. But as it comes back up the chain, it leaves these little breadcrumbs, these sticky notes in its cache. Hey, the answer to f of 3 is 2. That way, it never ever has to solve the same problem twice.
And this just shows the difference so perfectly. Tabulation starts at the bottom. It already knows f of 0 and f of 1. So it just says, okay, let's calculate f of 2. Got it. Now f of 3. Got it. It just marches right up the ladder, one step at a time. No recursion in sight.
Okay, warm-up's over. Now for the main event, the title fight. This is a big one you see in interviews all the time. Finding the longest common subsequence, or LCS, between two strings. This'll really test them.
Now, the logic here gets a little more complex. See, a subsequence isn't a substring. The letters just have to be in the same order, but they don't have to be next to each other. To solve this, you basically create this big 2D grid comparing the two strings. And for every cell in that grid, the logic is pretty straightforward. Do the characters for this spot match? If yes, great, we add 1 to our count. If not, no problem, we just take the best answer we've found so far from our neighbors. It's this network of overlapping problems that makes it a perfect battleground for DP.
And this creates such a cool way to visualize the two. Memoization is like a GPS. You tell it the destination, and it calculates the most direct route to get there, only visiting the spots it absolutely needs to. Tabulation, on the other hand, is like a road paver. It starts at the corner and just paves everything. Every single square, row by row, until the whole grid is filled. Systematic, thorough work.
All right, the fight's over. Both contenders did great, so let's head over to the judges' scorecard and see how they really compare head-to-head.
Okay, let's really dig into these trade-offs, because this is where the important stuff is. First, control flow. Memoization is recursive. Tabulation is iterative. Simple enough. But that leads to the big pitfall. See that risk of stack overflow from memoization? If your problem gets too deep, you can literally crash your program. Tabulation doesn't have that problem. Now, states visited. Memoization is surgical. It only touches what it needs. Tabulation can be a bit of a brute, solving everything, even states you might not care about. But, and this is a huge deal for interviews, Look at the space complexity. Memoization needs space for the cache and for the recursion stack. Tabulation's table can often be optimized like crazy, sometimes down to a tiny amount of space.
And let's clear up some common myths right now. First, memoization is always faster. Nope. Tabulation often wins because it avoids the overhead of all those recursive function calls. Second, you can't optimize space with tabulation. Totally wrong. In fact, tabulation is usually easier to space optimize. And the biggest myth of all, that they give different answers. If they're both coded correctly, they have to give you the exact same result. Period.
So after all that, what's the verdict? Which one should you reach for in your next technical challenge?
Here's your rule of thumb. You're going to want to use memoization when the problem just feels naturally recursive. When writing that recursive function is clean and intuitive. It's also your go-to when the total number of subproblems is huge, but you have a hunch you'll only need to solve a tiny fraction of them to get your answer. And you pull out tabulation when you see a deep problem, and that Stack Overflow alarm is going off in your head. Or when you realize, hey, I'm probably going to have to solve all of these subproblems anyway. But the real pro move, using tabulation when you know you can optimize the space. That's a huge win in an interview. At the end of the day, both of these methods are just two sides of the same coin. They both rely on Richard Bellman's principle of optimality. And that's really just a fancy way of saying that the best solution to a big problem is made up of the best solutions to its smaller parts. Memoization and tabulation are just different strategies for finding those smaller solutions and building them up.
So the real takeaway here isn't about picking a favorite. It's about being flexible. The truly impressive skill is being able to look at a problem, whip up a memoized solution to prove the logic, and then, if needed, transform it into a super efficient, space-optimized, tabulated solution. That's what separates the good from the great. So the question for you is, which one are you going to master first?